Thank you, Martin. Can you hear me? You forgot to say that we won 1-0 yesterday. Right? Ukraine won 1-0 yesterday, didn't we? Right. Good, good. Good. So thanks for having me. As Martin said, my name is Massimo Ferré. I'm a developer advocate within the compute service team, working primarily on containers, but at large on the compute services at AWS. As you can see, a little bit of my career, I came from VMware. I did a stint at IBM, actually more than a stint because I spent like 15 years at IBM. And I was a developer many kilos ago, like roughly 20 kilos ago. So it's a round circle here. But the reason for which I have this slide up here is because here there are my contacts here. So feel free to reach out either now, asking questions, or outside, or via Twitter or email. So when I present breaking the monolith to non-technical audience, I usually start with these two slides. We're going to get a little bit deeper than these two slides afterwards. But as an introduction, a couple of slides of introduction, what I usually say is that this is the typical setup when it comes to monolithic application, right? So you have like developers and people that think about building new stuff, and then you have people that are integrating those stuff and they put those into production. And the characteristic of the monolith is that it moves very slowly, right? As you can see from here, it moves very slowly. So what this means from a business perspective is that you can serve users, or the time to user is usually months or years, right? When one of these guys has an idea, it asks this guy, can we get this into production? And say, sure, in a year. Right, or something like that, as opposed to what we refer to as microservices, which is a very different setup. It is a very different setup, both from a operational perspective as well as from a technology perspective. So what we're going to cover in this session in the morning today is more skewed toward the technology side of things. So how you move the monolithic application into microservices. The session that I'm doing at the end of the day, it is more on the operational side of things. So what we're going to focus today, this morning, is how you break that monolith into different pieces to achieve that agility that I was alluding to. And then what we're going to talk about is the automation on how you put all of these things together, and we're going to talk about that later in the afternoon. Obviously, the advantage here and the characteristic is that once you have all of these different pieces, they can move at a different pace depending on your need, and this means that you get to your users much more with a much more agile perspective. At this point, when I do this talk to a technical audience, we usually have a couple of options, right? We either pontificate about how you should, in theory, build new microservices application, or you take a very practical example and you talk about this. So for this session, I opted to not pontificate about how you should, in theory, do that, but I opted to actually try to show you how I took my application that I developed, and deploy it into different models, from EC2 to containers, ECS, Kubernetes, all the way to Lambda. So talking about breaking the monolith is a very tough topic because it goes into a million different directions, right? So hopefully you're going to get something out of this session. I'm going to talk in particular about this application and the way that I build these applications. So I'm going to talk about Ruby and Nginx and other things that may not apply to the language that you use, but hopefully the concept are going to apply to what you do. And as a bonus, I do have a few demos. If it gets a little bit boring, no problem. You can raise your hand and say, Massimo, this is getting a little bit boring. Can you go on the demo? And we will do that, okay? This is a real picture of a guy that I took in the audience when I said that. Okay, let's start and get into the weeds. So when you have a a piece of code, there are a number of ways that you can take that piece of code to live on the AWS platform. Basically, there are three big buckets. Okay, so there are instances, EC2. I will assume that pretty much all of you are familiar with at least the concept of running EC2 and instances. Containers. We're going to touch on containers that I define as cloud as an opportunity. And then we're going to talk about function or cloud as a platform. By show of hands, how many of you are already using containers in any shape or form? Okay, good. I would say half of it. What about serverless, Lambda specifically? Okay, good, good. If we drill down a little bit, this is how we build on this, right? So I'm going to make an announcement and say that Lambda does run on servers, right? So there is this meme going on about, Lambda doesn't run up in the air. Of course it runs on servers, but the whole idea of Lambda is that it will abstract pretty much everything that is underneath. And those of you that are using Lambda knows about this already. I want to spend, so the way that I'm going to spend this next, 35, 40 minutes is by talking more about that application than the services itself. But I do want to spend some time on this slide just to talk about the services that we're going to use, right? So as this is a broad topic, I'm not going very deep into any of them, but I want to give you the high-level picture of how you can use these services and where these services fit. So the first thing first that I tend to say about this slide is that it is important that you understand this notion of the provider space and the consumer space, right? So provider space and consumer space is, provider space is what we do to serve you and what you let us do to serve you in terms of the IT stack, and the consumer space is what you do, right? So there are these two main differences, or that goes back to, for example, the shared responsibility model that we talk about very often. And then the other point is this different level of abstraction that you see on the right-hand side. This thing doesn't work very well, as you can see, but no problem. So on the right-hand side, you see physical servers, VMs or instances, containers, and function, right? So this is where you can intercept the AWS cloud when you have that piece of code, be it Ruby, whatever, Python, or Java, or whatever. Depending on what you want to do and what you want the AWS cloud to do for you, you may intercept the platform at different levels. So let's talk about EC2 and bare metal, which is kind of a little deviation from the standard EC2 instance, but I'm not going to talk about that. But EC2 is where pretty much everything started. So basically, we're responsible for the physical service that you don't get to see, right? And we are responsible for the hypervisor that we use to serve those EC2 instances. From that point on, it's all consumer space. You're responsible for the OS that you're deploying. You're obviously responsible for the framework that you choose to use and updating that framework, and obviously the code of your application. Throughout the years, what happened is that we have seen, starting 5-6 years ago, people starting to use another abstraction layer, which is the Docker containers. So we have started to see lots of customers using Docker containers on top of EC2. So what we have done throughout the years, starting 4 years ago, with ECS and last year with EKS, is we introduce a new abstraction layer, formal abstraction layer inside the AWS cloud, which is the container abstraction layer. So now and today, what you could do is you can take a Dockerized application, and we're going to talk a little bit about that, and you can deploy that application on EC2 instances orchestrated by one of these two orchestrators, right? EKS, which is upstream Kubernetes that we manage for you. So EKS is a managed Kubernetes service that we provide to customers. And ECS, that is our own container orchestration platform. On top of that, well, not strictly speaking on top of the container abstraction layer, but as an ultimate level of abstraction, there is Lambda. right? So if you think about the container abstraction layer, and we will see this as we go through the presentation, you're still responsible for a lot of things. This gives you flexibility of using the framework that you need and tweaking everything that you need inside that container, but you're still responsible for that. Lambda moves this concept to the extreme where you are responsible only for the code that you want to put into production, and we are responsible for everything that is underneath, including the framework, right? So you just say, for those of you that are not using Lambda today, I know it would sound a little bit basic for those that are using Lambda already, but think about it as I have my piece of code, Python, Java, Ruby, and I'm going to throw it onto the platform, and the platform will run it for me. Okay? So that's what we're going to use. Not talk about, but use as we move into the presentation. So we're going to take that application and move it onto these different layers that typically maps the journey that the customer does to move from a monolithic application that usually sits here in the stack. Monolithic application typically tend to use to run on EC2 instances, all the way up to Lambda, which is where you will find a lot of microservices type of deployment, by definition, I would say. So let's get into that application. So a little bit of history about this application. When I started playing around with cloud and containers specifically, I figured that I was exposed to a lot of tutorials that were like, you want to learn this piece of technology, you can run this demo application that goes with this tutorial, right? I was learning, but it was not as challenging as what a customer needs to do, which is, I have an application, how do I apply that specific technology to my application? So it's pretty easy to say, I want to learn, I don't know, Lambda or whatever, or EKS or ECS. Let's go through this tutorial that, gives me a very stupid application that has been written for that specific tutorial. I wanted to do something, backwards, which is I want to mimic a customer environment where you have an application, right? And then you see all these new technologies popping up, and you want to adopt that technology to your application. So this is kind of the background about this. So I built this application. It's a typical stupid voting app. It's not. I mean, when I'm going to talk about the business logic, business logic to me is n equals n plus 1, right? So focus more on the concept, not on the complexity of the application. The application looks like this. So there are really a couple of, I would say, from a code perspective, there are a couple of angles. The first one is the front end, which I developed in Angular. So it's a JavaScript front end. Not sure if you can see here, but it's pretty much here. And then there is a application logic, which is Ruby and Sinatra. Okay, nothing very fancy. It does use a Redis database and the Postgres database to persist those data in different ways, but it's nothing really fancy. This is how it works. So the Ruby application exposed a bunch of APIs, right? And you can see those APIs in here. So for those of you that are not familiar with Sinatra, it's just a web framework that runs on top of Ruby that will allow you to do things like this. So there is a Ruby server that exposed those 6, 7, 8 APIs. And then there is a front-end module, which is an Nginx server that does a couple of things. So the first one is it serves the JavaScript to the end user. So you hit the website and you download the JavaScript. And when you hit the /API endpoint, it basically proxies to the app server. That's how it works, okay? And then in the backend, there is this Redis and Postgres where I'm persisting this data. So what we're going to do here, and what we're going to talk about is how we move this application from an EC2 deployment to a containers deployment to a serverless deployment. It's I have defined containers as repackaging, and I have defined serverless as refactoring, right? Because containers is that weird construct where you can actually just repackage what you have. And I can tell you stories about this. I mean, customers that wanted to move a Windows 95 application into containers and crazy things like that, all the way to customers that are refactoring their application in true microservices using containers. So I'm taking a little bit of assumption here where I'm pitching containers as a halfway between just repackaging and refactoring. Whereas serverless and Lambda specifically typically requires a little bit of work to make it work in that specific environment. A few watch out before we move on. So the first one, before we get into the actual thing, this is how we're going to deal with security for this sample here. We're not going to be obsessed about security for this particular example and for this particular session, right? So security is our obsession, but not for these next 30 minutes or so, right? We do have other things that we want to look at. The other thing is that you will see me setting up databases in containers, okay? I, for one, I'm all for containers are stateless. So there are these two camps in the industry, like, oh no, we need to bring everything into containers, including big databases. And there are other people that are, containers should just run stateless code and data and state should be saved somewhere else. I'm more for the second, but the jury is still out, right? There are lots of customers that want to move data into containers. This is just to say, I'm going to instantiate data in containers, but I'm not suggesting that you do this. It's just for example purposes. The last one is that as we go through the presentation, you will see me instantiating all of the layers on EC2, all of the layers on containers, all of the layers on serverless. The truth is that you can mix and match this. So when we get to talk about Lambda, I'm going to show you how the backend database can be moved to DynamoDB, for example. Nothing would stop you from deploying the Ruby functions in Lambda and keeping Postgres and Redis in the backend if that is what you want to do, right? So, which is actually the essence of microservices in the end, right? So it's just you create independent modules that you can deploy pretty much as you like. So let's start with the EC2 deployment. So the EC2 deployment is pretty straightforward, actually, and you can think of it as something that you would have done back in the days for these applications. So we said that there are these four modules that are the Angular UI that lives on an Nginx server. There is a Ruby app server, there is a Redis server, and there is a Postgres server. This is nothing fancy here, right? So we're just deploying those things on top of, here. We're just deploying those things on top of EC2 instances, and the way that I'm doing this is pretty straightforward. I have already actually done this because it takes like 3-5 minutes to bring these things up. So I have already deployed with the CloudFormation template that you can see here. You should see here. There are a couple of actually CloudFormation template. One that deploys this in a distributed manner, so to speak, which is what you saw on the slide, which is basically an EC2 instance dedicated for each one of those 4 modules. And there is also a single instance. So basically, when you hit this one, you're hitting this IP address or a fully qualified domain name that represent the EC2 instance that is running the Nginx server. So there is no load balancer, there is nothing, right? So this one is what is serving the JavaScript to my client. This is the distributed one. The single instance one will show up pretty much similarly. This is a different instance, but this lives on a single EC2 instance where I'm installing Postgres, Redis, the Sinatra server, as well as Nginx. Okay, these are 2 different endpoints that I have deployed. As you can see here from the slide, this is the one of the 2 CloudFormation template. Everything that you're going to see here is on GitHub as a open source project, so you can test this on your own. What I learned about this deployment as I was doing it, and as we said before, this is not well architected. It doesn't have load balancer. It has lots of single point of failure. But what I learned about this when I was doing this, which is one of the main reasons for which people are moving to containers actually, is that this setup is very, very much sensible to the Linux version that you're running. Particularly some of those modules, maybe not so much the Postgres and Redis and other things, but the Angular, which I'm compiling as I deploy, it's very, very sensible to the OS or the AMI that I'm using to deploy this. So one of the main reasons for which people are moving to containers is because of this. The other thing, particularly for the distributed environment, is that I need to tell where the endpoint is. So for example, this is the Linux script that I'm using as part of that deployment for the app server. So I need to pass a couple of variables to tell the Sinatra server where the databases are, where the Redis database is, and where the Postgres database is. The good thing about containers, as you move to containers, is that a lot of these things gets abstracted, and you don't have to build these on your own, and you don't have to say the next hope, the next endpoint is at this place, because there is a lot of service discovery that gets with containers that will help you solve that issue right away. This is what I was alluding to. This is probably not a best practice, but I'm doing it anyway when I deploy with the EC2 model. So basically, I'm not using any artifact. I know that the best practice would be you compile your Angular application somewhere, you create an artifact, and you deploy that artifact. I'm not doing that for a number of reasons. We will touch on them later on. But this is a snippet of the script that I'm using to deploy the UI. So as you can see, what I'm doing here is I'm deploying the instance. I'm building the JavaScript output that I'm putting into that custom dist directory. I'm not sure if you can see that all the way in the back. But basically, the next step that I'm doing is, if you remember, I'm using Nginx both as a web server to serve this JavaScript package, which is what I'm doing here. So I'm basically saying the root website points to this directory here where there is the index.html. And the other thing that I'm doing is I'm configuring Nginx to, I'm configuring Nginx here to proxy. So I'm saying if you get hit on the /API endpoint, you need to proxy to this address here. Basically, the Yelp App Server endpoint, which is on another EC2 instance. Okay, so that's how I'm doing the EC2 deployment of these monolithic applications, so to speak. Let's move into the containers repackaging, EKS and ECS. So for those of you that don't know Docker, I'm going to spend like a couple of minutes to talk a little bit about what Docker does. So the magic of Docker is that you can define this Docker file. And again, I apologize for those of you that are already using Docker. That sounds a little bit boring. But for those of you that are not using Docker, basically you can script this file. Think about it as kind of the setup of your application. You can build your container image, right? So from that Docker file, which is a script that does a bunch of things, for example, compiling the Angular application so that you get your Docker image ready with the artifact in it. You can then run that Docker or container image into a Docker container on top of a Linux host, typically Linux host. So Windows is supported as well, but I would say the majority of the setup are done using Linux as a server. So that's pretty much what Docker does. The magic of this is that you completely decouple the Linux environment, the Linux operating system from the Docker container that you are running. A lot of people may think that this is what what VMs has been doing forever, particularly if you think about this complete decoupling here. If you think about what virtualization was doing 10 years ago, it was pretty much the same thing at the lower level, where you would virtualize your physical host and you would create virtual machines that would inherit this characteristic here. But doing this in the Linux environment helps you in a number of different ways. So the first one is that containers are usually a little bit lightweight compared to VMs, especially if customers are refactoring their application and creating more microservices. Those containers are very lightweight because they do not need to include the entire OS like virtualization, hardware virtualization would require. The other thing that is moving a lot of customers to containers is that they are infrastructure agnostic. So virtualization is very tied to a specific technology. You cannot take an AMI and instantiate it on another cloud that is not AWS, for example, and vice versa. Containers, a lot of customers like containers because the minimum common denominator becomes a Linux host. So you can have a Linux host in different infrastructure endpoint, different clouds, on-prem, and you can take your Docker image and instantiate it, exactly the same Docker image, and instantiate it everywhere. Containers have a developer-friendly packaging mechanism. That Docker file is, in my opinion, the real magic of Docker, where you can actually specify what you need your environment to look like. You build the image, and that image will remain consistent across different deployments, right? And it's a step forward to treat infrastructure dependencies as code inside that Docker file. And containers are also ideal for what we refer as immutable deployments. So if you think about the way that you would do things in the old world, so to speak, is you deploy your application and you maintain that application on the same EC2 instance, for example, using Chef or Puppet or whatever. You update that application as you have new releases. With containers, what you're doing is you're pretty much shutting down the old version and bringing up the new version, which is what we're going to see later on in the afternoon with that operational CI/CD pipeline that we're going to create for a demo application. And obviously, containers are easy to consume and to share. One of the main advantages and one of the reasons for which Docker skyrocketed in the last few years is because this notion of the Docker Hub and the fact that you just can install any piece of software, including Oracle databases, if you will, just running Docker run, blah, blah, name of the container, it's tremendously helpful. It's a sharing mechanism that made the whole community strive for that. So let's get, you're probably not going to see this, but if you think about this, I mean, this is the UI Docker file. So the next step was I have a Linux script that deploys my Angular application on an EC2 instance. How do I do this in a container world? So basically what I've done here is I took that Linux script, I modified a little bit. You're going to see this on the website, I'm not going through line by line here, obviously. But basically what I've done is inside the same Docker file, I'm implementing a very common pattern called multi-stage build, where what I'm doing is I am compiling that I'm compiling that Angular application into a JavaScript output. Okay, so what I'm doing here is pretty much similar to what I was doing in that Linux script. Okay, it will take 2-3 minutes to do this. And then what I'm doing is with the output of that compile, I'm moving it into another Docker image, which is from Nginx. So the multi-stage build is useful when you have something like this. If you think about what Angular does, it downloads half of the internet, pretty much, to compile that application, and it will spit a few megabytes of JavaScript. That's kind of, what it does at the high level. So what I'm doing here is I'm doing that thing that I was just describing. I'm building the Angular application here, and then I'm switching context. I'm creating another Docker image from Nginx, because that's the beauty of Docker. I can start not from a bare metal or bare bone OS like Ubuntu or Amazon Linux. I can start from the framework that I need, from the app that I need, and I'm just copying that output into this one. So I have a very lean, very small container image that only has Nginx and the output of the compile that I've done in here. And then I'm throwing this away. This is a very common pattern. The multi-stage build is a very common pattern. Also used for Go, where people would have a Go program. They would use a similar pattern here to compile that Go program into an executable, and then they would just use from scratch, and they will just copy the executable into that container. So the container image actually becomes as big as your executable, in fact, without having to carry on all the build space that you have you had to do. So these are the resulting images. So what I've done here is I built the UI with the Docker file that I showed you before. I built the app server. I built the database. This is nothing more than a Postgres. I'm basically doing from Postgres, and I'm just preparing the database. So there is a little bit of a script that goes with that image that set up the schema for that database to host the number of pages and number of votes and things like that. But this is pretty much stock Postgres, and I'm using completely stock Redis image. So within the configuration file for EKS and ECS, you will just see the Redis stock image. So when you have those Docker image, and we're going to switch to the demo in a second. Basically, you remember that we have seen these customers playing around with Docker and bringing up these containers on EC2 instances. This is what we're doing to move up the stack and intercept Kubernetes and ECS. So basically, Kubernetes or EKS, which is our managed version, a managed version of stock Kubernetes, and ECS, they both have different definition for how you bring up containers, how you tie services to those containers and things like that. But they all use the very same Docker image, okay? So this is the image that I'm going to use for the UI. This is the image that I'm going to use for the UI. As you can see, the syntax of the YAML files is a little bit different, but the concept is very similar, okay? So basically what I'm doing here now is this is a Kubernetes setup that I have, actually an EKS setup. As you can see, there are no pods running on these EKS instance. So, and there are no services. Services are basically how you, well, other than the cluster IP, which comes by default. So services is a way for which other services get to talk to that container. So what I'm doing here is I'm going to instantiate. So the test that I was doing. As you can see, what I've done is I ran a command that takes that YAML file that you saw here. Obviously, it's a little bit longer than this, but it's pretty much this file here. And I'm applying it to that Kubernetes cluster. So if I go back and say, get me the services, as you can see, I have created a number of different services like Redis, app server, the database, and the UI. As you can see here, the UI has also associated the load balancer, an AWS load balancer, because that's how the integration works. So if I go to the console on the load balancers, I will see that another load balancer is being created, which is this one. As you can see here, it needs to stabilize a little bit because there are 0 of 3 instances in service right now, because the load balancer needs to stabilize and bring in those instances that are running those containers. I forgot to mention that these are the 3 instances that are backing that Kubernetes cluster, okay? So basically, I'm deploying those pods on these 3 nodes here, and I'm telling the load balancer, address those pods that I've just created. Actually, is address that single pod, which is the UI pod that I've just created. So the pods should be up by now, as you can see. So the pods are running. They are all ready. And the load balancer is going to stabilize in a minute. The other thing that I wanted to show you is how you would do the exact same thing using ECS. So for ECS, we're going to use this single cluster. I'm sorry. We're going to use this default cluster here. Here. Okay. I didn't touch on this when we talked before, but the cluster really has a couple of dimensions. The first one is the EC2 dimension, which is similar to what we have seen for Kubernetes, where you need to give EC2 instances to back that cluster so that I can run tasks. Okay. The second dimension is what we refer. This is the EC2, and this is Fargate. So Fargate is our response to customers saying, I don't want to deal with an infrastructure where I need to deploy containers. I know that in order to deploy hundreds of containers, I may need dozens of EC2 instances, but keeping up to speed with those EC2 instances and scaling them up and down and patching them is a lot of work. So I want you to manage it for me. Right? So what we introduced last year is Fargate, which is a managed, sort of a serverless for containers, if you will, where you deploy ECS task on top of an infrastructure that you don't get to see. As a matter of fact, what I'm going to do next is I'm going to deploy that same application on ECS on the default cluster that doesn't have any container instance, so I couldn't deploy it here. It would just error out if I try to do this here. And I'm deploying it on top of a managed Fargate infrastructure. The way that I'm going to do this is by using this CloudFormation template that it's on GitHub, so you can test it yourself. So this is the repo, basically, okay? This is what you can clone. If you go to deployments, platform deployment, AWS, ECS, there is this CloudFormation template that will allow you to deploy. I'm going to give it a name, or let's call it Yelp ECS, cluster default. The good thing about this is that I can specify the number of application server tasks and the number of UI tasks right in here. And then I can also define the launch type. So I can say Fargate or EC2. As I said, I'm going to pick Fargate. I want to give a public IP address. I'm going to pick a couple of subnets. And I'm going to pick the VPC. So if I move here and I click on the default cluster, I should see momentarily services coming up and tasks coming up. Very similar concept to what we have seen with EKS before, but in a different environment. Let's see if the load balancer has stabilized here. Not yet. But as you can see, this is the one that the ECS deployment is bringing up. As you can see, it says provisioning. Let it stabilize for a second. So this is what I've done here, okay? So this is the EKS control plane. These are the EC2 instances that I had in my account, and this is what I've done. Running that script, when you saw me doing kubectl create-f, name of this file, this is what it brought up, okay? And that is the ELB that created to point to the Yelp UI. This is what I was doing with ECS. Okay? So I'm now talking to the ECS control plane. Actually, I don't have EC2 instances in that default cluster, so this is not actually what I was doing. But if I had EC2 instances, I could bring up using that CloudFormation template that I just showed you, I could have brought up this pretty much in the same way. What I've actually done here is this. I have used Fargate, so you're not dealing with the infrastructure at the lower level. I just brought up the very same stack on top of Fargate. And this is the CloudFormation template that I showed you before. This is where you toggle between launch type Fargate and launch type EC2. Okay, this is coming up, as you can see. Those are the services, and these are the tasks that are coming up. Possibly, this one has stabilized now. So if I go here, and I click, and I open this one, this is the EKS one.